and my voice is not cracking anymore, which is good. I got called out in chemistry lab yesterday because the only way I could speak without my voice randomly going between octaves was to whisper. So I was whispering to my lab partners since it was a group thing, and Mr. Liu yells back, "You don't have to whisper," and I was like, I can't speak any louder. Elise had to say that for me, but it was just kind of embarrassing. He's great at embarrassing people for doing nothing wrong. But feels good to be Wednesday. You're just finding the area using rectangles? Yeah, our stop before I got there, because Jim said to go not getting over it at night. I'm a morning person. I'm a morning person. Hey, Chloe, what does your schedule look like next semester?
Statistics, one for history, 132, English, not even this class. Something else.
I might have a high school after that.
Not ready for college. In creating code. That's what I get out of it.
The two main classes I need to take are Bio 112 and Chemistry 115. But I'm on the wait list for chemistry.
You only have 3 classes.
Well, I'll still have like Spanish and stuff,
Oh.
but I'll be able to take Calc 2 because of both Bio and Chemistry.
Thought it would work me.
Audit what?
Audit this class.
You can do that?
Next semester. Yeah, we just have to ask him if that's okay.
I would like the knowledge without the grades.
True story. Also, Miss Turner is taking Talk 2 here next semester.
Really?
Okay. Basically, what I'm confused about is on like 27 and 31, how is B that much different than A? Because I would get A and I get the right answer for A, but then I do B and I get the wrong answer for B. And I don't know where I'm going wrong because I got the right answer for A. And that happened twice, so I'm pretty sure I'm doing the right thing. Those numbers? Specifically 27 and then 31. I'll show you.
One of them's less zone and the other is midpoint and lower.
No,
So you can't explain why, right?
because for 27, for A when it has the 3, I did it and I got the right answer. And then it has B when N is equal to 6, and it's supposed to be 6, yeah, but I kept getting 27.5. I was gonna go.
It's the last day of the summer.
Well, I'm not sure. Generally speaking,
For 27A, your delta x is 1.
Mm-hmm.
And
it's like
30
pretty sure.
B,
However, class is
yeah, just look at the difference.
so. I still can't, as a policy, we are, but
Take a screenshot of that.
for discussion. But so looking at class, I don't know.
Because
Because 11, even if it's not what we want to do, sometimes I like to hold it to the last moment. See what I don't know. See
You can scroll down and see 31.
the other classes are more than as yourself, people out there on board. Doing something else.
Yeah, it's a structured research.
This is here. How that makes how to do that. Well, so if you can't get in a business class, it's always full, so you probably won't be in it. Maybe it'll take you out to here. So that would be that would probably be, come forward and come and say, okay, let's run this. Do a little improvement here, but is it something that works? Different time. We changed it to 2 o'clock.
High schoolers aren't in it, then you could move it fine.
And we can actually, if we needed to, that's true.
Yeah.
I have schedule because trying to schedule a reach. The day, so if we needed, if there are people's schedules, but there's a couple of people already involved in that. If everyone agrees, that's how we saw it. We don't have to do that. Okay. Let's see where we go. Up to time.
I'm already at work.
That's about the time.
Well, I'm in
Amy, can you speak today?
A little bit better. I'm a little hoarse though, so
I'm glad you're feeling a little bit better.
thanks.
How's your neck, by the way?
It's doing better. I'm going to a chiropractor pretty much every day, so.
It takes a while to get that cleared up. That's
Yeah.
so, this is Brittany fell.
Or just don't fall downstairs.
Okay, so we're going to get started now. I want to, have the opportunity to work a couple of examples if we need to. That's great. Before we do, I want to talk about one concept from section 4.2 that we did not talk about yesterday. Because we ran out of time. It's not a big deal, but it is something to at least wrap our brains around a little bit. So, question is that I'm thinking about in my mind. We only did yesterday functions that were positive. So f of x that I showed you when we did an example, I did the parabola. The function was above the axis. So it was you had positive f of x values. What would happen if the function went below the axis and you had negative f of x values? What would that mean? How would you handle this thought? Are you with me here on this? So, as an example, and as a practice, here we go. This will just start us off. So, let's say that f of x equals sine of x, and use the interval from 0 to 2 pi. And let's calculate okay. So what? Before we get going, let's make sure we all got our minds wrapped around what we have, what we're trying to do. So f of x equals sine of x. And I'm just going to draw a picture. You don't actually have to do this. Solve the problem, but I'm going to do it just so we have an image of what's going on. I'll draw not a large scale graph, but at least try to get a reasonable graph on here. So there's 0. Let's say that pi. There's 2 pi. And sine of x goes up 1, -1. So it's 1 about there. It's 0. It's -1 about there. It's 0. Something like that. Okay, so there's my my graph of y equals sine of x that we remember from trig on the interval from 0 to 2 pi. And we're asked to find m of 8. What does that m of 8 mean? Point sum with how many rectangles? 8 rectangles. So that means I need to figure out what delta x is. First of all, let's do that. Delta x equals what? 2 pi minus 0 over 8, which is 1/4 pi, or pi over 4. Okay, so if I do that, then my rectangles, I'm going to have, one of my rectangles goes right through there, I think, 1/2 pi, and then halfway, 1/4 pi, right 2 pi, almost halfway. One of them goes right through 3/2 pi, and 2 pi, halfway. So my 8 rectangles will be formed by that subdivision set. I laid down my black pen. That was not. Which one was my good black pen? So we want to do midpoint sums. So graphically, that means I'm going to go to the midpoint interval. So that would be like right there. And on cap. So right there. On cap. Right there. On cap. Midpoint. I go to midpoint. Here's where we haven't discussed before. When I go to the midpoint on this next subinterval, my midpoint is going to yield a cap that's on the negative side of the axis. So I'm actually going to get a rectangle that's below the axis. So all my rectangles over here above the axis. Also, I'm going to get a rectangle that's below the axis. I'm going to go to the midpoint here. I go to the midpoint there. Go to the midpoint there. Okay, so now I get my 8 rectangles. I see 8 rectangles in here now. Again, I could have done all this without actually drawing the picture, but it's still, I think, instructive to see the picture. I'm going to find the sum, midpoint sum. So let's see. I'm going to see if I can start off with midpoint sum. So k equals 1 to 8. And midpoint means I'm going to find the average of each midpoint. So of each interval, so x of k minus 1 plus x of k divided by 2 times delta x. So I'm finding the average x value, and I'm finding the height of that average x value, and that is multiplied by delta x to get an area. So let's go ahead and do that. So that means I'm going to do, for k equals 1, I'm doing the average of x0 and x1. So I'm again going through the whole process. You don't necessarily have to show all these steps, but I'm kind of going through the whole process here. So I've got f of x0 plus x1 over 2 times delta x, plus I'll do a couple of them, then we'll get on down to the actual work. Then the next one I'm going to do x1 plus x2 divided by 2. times delta x, and so on. And the last one is going to be, I'll take the last 2 points, which will be x7 plus x8 over 2 times delta x. So all I need to know are what my x values are. Well, let's see if we can figure those x values out. Just list them down here. So x0 is 0. That's the first point right here. X1 is the next one over here. That's x1 is delta x over from x0. Well, delta x is 1/4 pi, so x1 got to be 1/4 pi. And x2 is another 1/4 pi over, so that's half a pi. x3 equals, go over another 1/4 of pi, that's 3/4 pi. x4 and so on is pi. x5 is another 1/4 pi, so that's 5/4 pi. X6 is another 1/4, so that's what, 3/2 pi. X7 is 7/4 pi, and X8 is 2 pi. So I have all my, those are the x values of the red lines. Are we clear on all that? These numbers, folks, once more, these are simply these values here. I just calculated the x coordinates of each of the subinterval endpoints. That's all I did. Now I got to use these in this formula. I'm going to average x0 and x1, 1/8 pi, I guess, right? So average of 0 and 1/4 pi is 1/8 pi. So I get an f of 1/8 pi times delta x is 1/4 pi. Then I got to do, this time I guess I'll go and do them all out. I have to average of these two, which is halfway between 2/8 and 4/8 is 3/8. F of 3/8 pi times 1/4 pi, and so on. Average between, let's see, we just did 3/8. The average between these is 4/8 and 6/8 is 5/8. 5/8 pi times 1/4 pi. And this wraps around, and the average of these two is 6/8 and 8/8 is 7/8 average, so f of 7/8 pi. Then average of these two is 8/8 and 10/8, so that's a whole 9/8. I guess I could have factored out that 1/4 pi, but I didn't do it. Average of these is 10/8 and 12/8, 11/8. F of 11/8 pi. That's 1/4 pi. And then average of these is 12/8 and 13/8 average. Oh, I wish I had room, but I guess I'll just carry it around here. Average down here is 14/8 and 16/8 must be 15/8. F of 15/8. Okay. Why don't y'all take a minute and use your calculator now and actually calculate this. In other words, what I would suggest doing is, like I said, back up 1/4 pi. So you're just doing sine of 1/8 pi, sine of 3/8 pi, plus sine of 5/8 pi plus, and doing all the odd 8 pi's, and the last one you get to is going to be the sine of 15/8 pi. And then once you get all those calculated and add together, they multiply the whole thing by 1/4 pi. See what happens. Let's make sure you're in radian mode. Radian mode is critical here, folks. Radian mode. Go ahead and take a minute or 2 or 3. Shouldn't take that long to calculate that.
Getting decimals.
Number anyone? Oh, hey. How to see it. So the answer came out to be 0. I agree with that answer. Because why?
Just negative
Yeah. By the symmetry of the sine graph on the interval that I gave you, there's as much area under the upper curve as there is under the lower curve. So you're multiplying by positive heights here, and you're multiplying by negative heights here that are of equal heights. So they're canceling each other out. So what we do is we call this signed area. So this is the Riemann sum. The whole point to all this is Riemann sum gives what's called the signed area, also known as that area. So the point is, one more time, that we had not discussed was if the function goes below the x-axis, the heights of your rectangles are negative numbers. We don't make them automatically positive, unless there's a point to it, which we'll discover later. But for now, you just let your function value be either positive or negative, whatever it is. We call it a signed area. Let me help you see this in another way real quick. Then we'll entertain questions from the homework. So one more time, this one came out with a 0. But let's imagine that this graph velocity function of one of our walks. The velocity function of one of our walks. So describe the velocity function. Now, how am I going to walk this? This is my walk velocity. So going back, way back to how we started, think of this as s prime of t. So that's my velocity function. How describe my walk? What do I got to do?
So you got to accelerate for a certain distance to decelerate that.
Okay, you're gonna accelerate, and you're gonna kind of come to a slowdown, to a stop, and then you're gonna start going backwards, faster and faster backwards, then you're gonna slow down and come to a stop. And the amount of time you spend going forward, accelerating and slowing down, is the same amount of time as you spend going backwards at the same pace. So I'm going to start off getting faster, and then I'm going to slow down, and I'm going to go backwards faster, and then I'm going to slow down. And what happens to my position then? Get back to the same spot. In fact, now let's take it one step further. If this function, sine of x, is s prime, so taking back last block, so if f of x, we'll call it f prime now, if f prime of x equals sine of x, then what is f of x? So I'm talking derivatives now again. if the derivative function is sine of x, going back class before, what is the function whose derivative is sine of x? It is negative cosine of x. That's correct. Let's take a look at the graph of negative cosine of x. What does the graph look like of negative cosine of x on 0 to 2 pi? Cosine of x starts high and goes down like this. Negative cosine is just a mirror image, so it starts at negative 1, comes up to 1, back down to a negative 1 at 2 pi. Look at that, folks. This is now my position function. What do you observe about the position? It starts and ends at the same position. That's position. How does it be negative 1? But it starts and ends at the same position. So going way back 2 blocks ago, when you found net displacement, that was the change in position. What's my change in position here? 0. So net area is the same idea as net displacement. Are you with me there? And we started that thinking way back when, and then just when we introduced Riemann sums and this whole concept of area under the curve, I started the discussion one more time with, if I'm walking at 2 feet per second or 5 seconds, then my position function looks like that. That's 5 seconds. Then I reach a position of 10, and that's my net displacement. So I had a net displacement of 10 units from 0 to 10. So net displacement equals 10 units. On the other hand, we talked about it when we introduced all this, so just kind of trying to tie it all back together. We talked about S prime for this same plan at 2 feet per second is a simple function like that. There's 2. And we discovered that the area underneath that curve, this area equals 10. That 10 is the same 10 as here. So this would be called net area. And that net area of 10 underneath that curve is the same as the net displacement of 10 units on this curve. So beginning and ending at the same position on this position curve ended up with a 0 area under the rate of change curve. Okay? Anyways, in this section, the one thing they've mentioned that I had not mentioned was if the function goes below the axis, that's okay. You just count it as negative area. I know generally speaking in geometry, we don't talk about area being negative. So it has a meaning other than negative area. And it has to do with, again, this idea of net displacement. Okay? That's it. That's the last of the new topics in 4.2. That was the one thing we had not discussed. So now questions on the homework. I have problems at 4.2 that they felt like I just have no idea how to do. Extra pride. Yeah. What was that? 31. 31?
Actually, no.
Oh.
Yeah, 30.
Wait a minute now. What is it?
I don't know. I'm trying to figure it out.
Which one did you try and not have to be successful?
I think it was 30, actually. I think I actually did 30. You know,
30, okay. 30 was not assigned, but we'll try it.
Yeah.
Since you gave it a try, we'll give it at it. So let's see if we have room here on this board. 30 says f of x equals 1 minus 2 to the x. And my interval is 3 to 1. And n is equal to 8. And we're supposed to find two things. We want to find the left sum at 8, and we want to find the trapezoid sum at 8.
No, it's a right sum.
Oh, it says the right sum. You're right. I read the wrong line.
Yeah, that's about it. I get games for different problems.
Maybe we should do the trapezoid sum because I feel like it. I just changed the game plan on that. Feel good. All right. So now what?
I'm your delta x.
We need delta x. Okay. Always going to have a delta x. What's my delta x? Minus -3 over 8, which is 4 over 8, which is 1/2. Okay, left sum at 8. So left sum, at this time I'm going to do, I mean, we can draw a picture, but 1 minus 2 to the x. What does that look like? 1 minus 2 to the x. So that has 2 to the x normally does that. We turn it upside down and shift it up 1. So we got an asymptote at 1, and then it does something like that.
Yeah.
So apparently we're going from -3 to 1. So maybe from here to there, where 1 is, I don't know. No, 1, that wouldn't be 1. 1 would be there. So we want this area in there. That's what we're looking for. Oh. Oh, that's above. I'm sorry. We want between the axes. Here. Oh. So one in there, that region of the curve between the x-axis and the curve. And I know I can go in. I want to list my x values. That might be helpful again, just to have those listed out. So x0 is going to be the first value. X1 is the next one over, which is half up from there, so -2.5, so -5/2. X2 is 1/2 more than that, so that's going to be -2. And X3 is 1/2 more than that, so that's -3/2. X4, 1/2 more than that, so that's -1. X5 is 1/2 more, is -1/2. X6 is 1/2 more, is 0. X7 is 1/2 more, which is 1/2. And X8 is 1/2 more, which is 1. Okay, so I have all my x values listed. To calculate this means just kind of skipping a couple steps, going straight to it. I know that I've got to use the left endpoints 8 different times and multiply by delta x. But I'm gonna do the multiply by delta x at the end. So delta x is 1/2. So I have to do half of the left endpoint. First one is -3, and then the next left endpoint is -5/2, and then -2. Hope I left enough room for all this. F of -3/2, F of -1, F of -1/2. Just moving up though. F of 0, F of 1/2 times 1/2. So why don't I? Wait a minute, he's going to ask the question. Okay. Anyways, why don't I use the last endpoint down here? That would be a right end. I want only left ends. So I did all my left ends. And now it's just a matter of plugging that in to the function. whatever that makes. Use your calculator. Question.
Did I do it wrong? How was that? How did you know what to score at?
Well, because the interval is from -3 to 1. So on the way we do it, the left end is x0 every time. Okay. And the right end is always going to be the last one, so it'll be x8. So it's just a matter of making 8 subdivisions in there, each of them being a width of 1/2. So if I always start at the left end of my interval, I can calculate my x values just simply by adding delta x all the way across. So that calculator, I mean, you get some number from that. This time it's not going to be 0. And then let's try the trapezoid rule. Since we get a number on that. All that picture just a little better. Calculating. So at 0, that would be 1 minus 1 is 0. So it goes right there. So I'm looking at, I'm just messing around while y'all calculating, trying to, that's 1, 2, 3, so there's -3. 1 would be right about there. That positive area and that negative. It might come out close to 0, actually. Now that I look at it. What'd you get? Try to do a better sketch of my graph, taking a moment to think about it. Calculated number yet on using your technology? So you done? You got a number?
I don't know if it's right though.
Or so what'd you get?
Let's hear it. We'll try.
No, 1.54444.
Yeah, I got 1.7.
Anybody else want to second that number?
What'd you get, Chloe?
I got 1.73667.
1.59.
I second
Here,
Chloe.
1.5.
I got
So what?
1.73667.
I got 4.7. I got that second.
I got a 1.59. So it's probably somewhere in that range. Sam, what's yours?
1.24.
No, we should just not.
Let's just take that.
Mr. Gaddis,
Yes.
when it comes to finding a sum and like having to add it with a calculator, are you gonna give us leeway on the test, or is it gonna have to be something exact to like the digits and stuff?
Well, I mean, every calculator ought to be able to give me the same decimal approximation for this problem. There shouldn't be that kind of variation. So that somebody somewhere isn't hitting the right button somehow. I don't know. The 1.7.
Yeah, I got that.
Is. Yeah. Two people saying that now. So, well, I don't know how y'all are doing it. I didn't tell you how to do it. You're supposed to calculate it. There's a couple ways. On your home screen, you can type in 1 minus 2 to the -3 plus 1 minus 2. I mean, you can do that. Or you could create a function in your calculator.
Mm-hmm.
Could do it on the home screen. Function of. Y'all with me? What I mean here?
Yeah.
I'm not even good at that. I don't know how long this is. So I'm not comfortable leaving it at 4 different answers. I had 2 people saying 1.736, but a lot of people saying different things. Might need to try it one time. Project this on these pages so it doesn't for them and share it. Yeah, share it. Okay, so I'm using a older model calculator, TI-83, but again, I'm not paying to buy new software. So what I'm going to do is go in here and I'm going to create this function as 1 minus 2 raised to the x. Then I'm going to quit that. Notice how I've got like y1 of 5 right there. I'm going to do that same game here. So parentheses, bars, y bars, function, y1. Takes some time, but I can do this and make sure I'm not messing up anywhere else. What is it? -3. You can do a lot of different ways. And so on, plus I just do all of them here. Understand? So this is what I'm saying is an alternate way of doing it. Rather than having to type that calculation every time. Modern calculators, you can select the function name right from the home screen. This one I can't. But like if you have a more modern calculator, you can choose right off here. I don't think it'll work here on this one, this older one. But anyways, you can set up your calculation that way, and that would calculate y1. It's going to calculate evaluating this function at -3, and then you can do the at -5 and so on. That way you're not retyping 1 minus 2 to the x every time. Or if it was even a bigger function, you're not retyping that whole thing every time. You're just doing it one time and then referencing it through the function command. So I've just lots of ways to do it. I'd like to get more than just 2 people saying they got the same number. Let's try again and see if we can get the right answer or all get the same answer.
For example, if you just not the total F sum. Okay. Okay, good.
That's absolutely.
Hey, I got answer again. What?
I got a different
No,
answer.
I know.
Hey, look.
Can't use the word.
My calculator has a function that is weird.
I had one, you know, this
See,
one.
now I have one.
Found the actual area.
You mean it?
Yeah.
You found the exact area.
Yeah, I'm not.
We're looking for approximation. You're 3 steps ahead of us. So you have some way to do that. I don't remember how now, but I've done it.
Wait, that's the older model, huh?
May not be able to on this, but you can set up sequences and sums.
What?
There's a way to do it, I just don't remember how. Okay, so I need to come to a consensus here of some sort, and ideally the consensus would be unanimous.
Oh, yeah, I got his number now. We got
What
4
number did you
people.
get?
736.
People have what now? What you get?
We got 1.736.
We got 4 people with that, so that's got to be the answer. Okay, we're gonna.
I don't know about Popular vote.
Seems that we've got the answer now.
I got that.
As long as you can
Okay, swirl it. Now you do the trapezoid rule. We spent that time just finding 1.736. So now the hard part of that was apparently using our calculator. Let's try again with the trapezoid rule. Trapezoid rule. How does that work?
Oh, well.
4.5 is plus height.
The trapezoid, you gotta do that real quick and then we'll do it. When we're doing trapezoids are, well, in this case, it's going to be shorter on the right side, so I'll make it look like that. So I got a curve that's kind of doing that. So I'm going to come in here, and I'm going to make a straight line connection between those two endpoints rather than a horizontal line. And that forms a trapezoid. And this is called base 1, that's called base 2, and this is called the height. And the area of a trapezoid, as we talked about yesterday, can be seen as a rectangle using the average of the bases. So base 1 plus base 2 over 2 times height is the area of that trapezoid. In our situation, the base 1 and base 2 are the function heights, and the h is delta x. So this becomes f of x sub k minus 1 plus f of x sub k over 2 times delta x. So that's the trapezoid rule in general.
Mr. Gaddis?
Question, Rizzo?
Yeah, can I ask what makes the trapezoid different from the midpoint? Because you're finding the middle of it.
Well, for a lot of functions, it's very similar. You're right, because the midpoint, if you're looking at the area, you're right, that's going to be very similar to the midpoint, unless the function behaves very unusually. So you're right, that's going to be, for most functions, that's going to be the same. Good observation.
So, but I should still just go with the book and use the formulas for what they're asking.
Yeah, let's just do it. Let's see if we get the same answer this time.
Okay.
Okay, and the other thing I said yesterday about the trapezoid is that because you're using you're doing side-by-side trapezoids, then this B2 here gets used twice. And so the first left edge gets used once, the last right edge gets used once. All of the in-between edges get used twice in this kind of computation. So if you remember, what we said is this can be handled as f of negative 3 plus 2 times f of negative 5 halves plus 2 times f of negative 2 plus 2 times f of negative 3 halves plus 2 times f of negative 1 plus 2 times f of negative 1 half plus 2 times f of 0 plus 1 times, oh no, that's not, oh, that's the left. So I have to go one more. 2 times f of 1 half plus 1 times f of 1 all times delta x over 2. So 1 half over 2, which is 1/4. So we factored out the delta x and the 2 out of the whole thing, like we factored out the delta x here. Factored out delta x over 2. And because of the way the trapezoid is working and you're adding bases together on each side of the trapezoid, you got 2 of each of the bases in the middle and 1 of each of the bases on the end. So let's see if that comes out the same number.
Here we go. This is what
Oh wait, we didn't do midpoint, did we? We just did traffic. We just did left. We'll let you do midpoint if you want. Try it out and see what happens.
No, it was just a half.
If you're looking, using this, I'm not speaking.
No, it's
Okay,
okay.
okay.
They're taking time to
If
calculate
you're
our
looking
issues.
at the displaced area, so if I'm looking at that whole theorem, using, whether it's trapezoid or layout, shouldn't it be close every time?
When we do the limit, as n gets very, very large infinity, then they will all come out the same.
Okay.
It won't matter which one you use. If it's a small number of subdivisions, then they can differ. Although Rezo's question was that if I go to the midpoint of this interval here and make a rectangle like that, then that midpoint rectangle should have the same area as that trapezoid.
So unless your function is doing something really bizarre,
Yeah, like really
midpoint
crazy.
and
Trapezoid
the
should-
trapezoid should be very
Pretty close to the same. Now, when you start changing directions, the difference is that here, as long as I'm always a certain concavity, like this, always concave down. When I concave up, trapezoid's always going to be too big.
Yeah.
So I think, in fact, we learned, and I think we go over to the not next section, but a couple sections later, we talk about the error of the different approximations.
Yeah.
And they're not identical, but for a lot of functions, they can be the same.
So you learn all these ways so that when you get in the application, which method is the most accurate.
Right. Then you have methods of determining how many rectangles do I need within a certain tolerance of my. Even though I don't know the final answer, I can predetermine how many rectangles I need to determine the area to within a certain level of accuracy. And that's the long, a little beyond our scope, but that would be the bigger. I mean, we'll cover that, but from the engineering applied aspect, that's what we're
Deal.
So you'll divide it by 4 after.
Why would you divide by 4?
I just factor out 1/2, not put the 2 with all those ones that you multiply by 2.
So
For 2, you would have to divide. Like,
while they're still finishing, the concave up.
I didn't factor out any,
That's
because it's already on.
I know, if I did it something.
I got
that's midpoint would still be the same, but I don't believe their error computations are equal. I think this would have to go back. Wait, so you get a number? Tell me, this one should be different than the left stuff because we didn't travel it. But it shouldn't be, I wouldn't say wildly different, just not that. Oh. What do you get?
That's something really weird.
Oh,
Boy.
That's
That's what he said to do.
no, that's not.
I else get 1.268?
Nope.
Yes, I got that.
Yeah, thank you. Sammy had got also good. Thank you. Anybody else? That's 2. I'm gonna trust it, I think, by now. Hopefully we're getting the idea.
Mr. Gaddis, I have a question.
Question?
What did you factor out of that really long thing below T of A?
It's definitely 2.5.
When you listed out everything that you were going to add together, what did you factor out of it?
Very confident in
I hear you come out.
mine.
I'm not,
What did you say?
I'm not clear what your question is about what. Are you talking about this expression right here?
Yeah, that 1/2 over 2 at the end.
Okay, why?
Does that mean
Where
I
did
just
that come
divide? Does that mean I just divide my sum by 4 once I calculate everything?
Yes. 1/2 is my delta x. So this is delta x.
The air.
That 2 comes from the average
And you change the
base right there. So this is the
Comes from
average base.
Factor
And
Okay.
this time, I mean, it's not always you're just going to divide by 4, but this time because delta x is 1/2, then half of 1/2 is 1/4. if delta x was 1/10, then you do 1/10 divided by 2, which is 1/20. You understand, Rizzo?
Okay, so what do you mean by average base right there?
Average base, that's the average period. When we get the area of a trapezoid,
Mm-hmm.
the average of the two bases, base 1 plus base 2 divided by 2 gives me the average base length. You just talked about how that gives you the midpoint. And then times the height of the, which is the height is the perpendicular distance between the parallel sides. And that would be delta, so that's delta x. The base 1 and base 2, those are the function heights. So I'm just averaging the two function values. So then I'm going to, in the trapezoidal sum, which I didn't write out, if I write out the Riemann sum of it, it's simply the sum, k equals 1 to n, of that.
Mm-hmm.
So that means I'm averaging each pair and then multiplying by delta x. But if I write it out in expanded form, then I could factor out not only a delta x out of each of those like we've done before, but I can also factor out this too. So that's where, back over here, I'm adding up all of the function heights, but I'm doubling the ones in the middle because I'm using them on both the left and right. They're like this edge is a base 1 in one trapezoid, and it's a base 2 in the other trapezoid. And then that edge is a base 1 and a base 2. But the end ones are only a base 1 and only a base 2. So you got doubles of all the others because you're using them twice. But I factored out the delta x, and I factored out the fact that I was dividing by 2 to average the base. And all that got factored out of all that addition, so I could just do the addition and then multiply by that constant value. Does that make more sense now, Rizzo?
Yeah, it makes more sense now.
Okay, good. So we need to 8 minutes. Oh my gosh. And where does time go?
I'm sorry, maybe
20, no, 13 minutes. 13 minutes. Okay. Let's talk a little bit, get you started on the next section a little bit. We're not going to cover all of it, but let me just give you the initial definition in the next section. We'll talk a little bit about it.
Oh, boy.
I'd like to have time to finish up, easily finish tomorrow. That leaves us Monday to review, and then Tuesday is your test. Okay, so I want to go ahead and get us started on the next section. Lesson 4.2 is just doing what we've done for different types of sums to approximate the area under the curve, which is a signed area, because if it goes below the x-axis, then it's a negative area.
Just kidding.
So we're going to define function f of x with one sum summation k equals 1 to n f of x sub k star times delta x. That's where we started 2 days ago. Is this concept here of Riemann sum? So, or maybe that was yesterday. And again, there are certain conditions on that. You know, where delta x equals B minus A over N, and X sub K star is a member of the K subinterval, which we wrote as X sub K minus 1 up to X sub K. So this is so if we're given this function and this Riemann sum based on that function, then we can define, the definite integral on interval A to B is, or as, and we use this symbol, elongated S. It has a subscript of A and a superscript of B.
Looks like forte to me.
Same here.
Then f of x. Then we have a dx on here, just like we had when we were doing derivatives. This is this symbol, and I'll write down what it means in a second, but that symbol is called the definite integral right there.
Oh gosh, it makes sense.
This thing right here is called the definite integral.
Mm-hmm.
And it is defined as the limit as n goes to infinity. Let's make this familiar, like I think we did that a couple days ago, of the summation A equals 1 to n of f of x sub k star times delta x.
It makes sense. Oh my gosh.
So the definite integral is defined by, it is simply defined as the Riemann sum that we've just been exploring with the extra thing that we're going to let the number of rectangles go to infinity. So that's where, as I was alluding to yesterday, knowing how to handle the sigma end of things, with the limit n goes to infinity, that will be important to us in the Riemann, when we get to the definite intervals. When you're doing a small number of n like we've done over here as an approximation, that's not a big deal. But now, definition of definite interval is limit n goes to infinity. So that means this is going to give me this is in fact the exact signed area rather than an approximation of signed area. This thing here gives the exact signed area. Because it's like with the lake problem, the lake lab, we discovered that if I make smaller squares and fit them better into the lake, then it comes closer to the exact area of the lake. Well, the idea is if you can make the squares shrink down to a single point, single pixel, if you will, then they fit perfectly in the lake. They make exactly the area. Each little pixel is a small amount of area, but it adds up to the whole lake. And the same idea here, if we make the number of rectangles grow to infinity, then the width of each rectangle is going to get very, very small. And effectively, you just become just a little line, vertical line almost. And add up all of those, and that's going to be the exact area, exact sign area. So that's called the definite. Rules that apply to that we can also study, but we could now do a simple one fairly quickly. Let's do one example with this just to make sure we know what we're talking about here. So, do you remember the one we did yesterday? I think we have time to do this. The one we did yesterday, 4 minus x squared from 0 to 2. Do y'all remember that one? Okay. So instead of approximating, let's find the exact area. So again, the function was 4 minus x squared on 0 to 2. And yesterday we did an approximation. I don't remember how many 4 rectangles, whatever we did, I don't remember. But the picture again is a parabola, and we're going from 0 to 2. And now, instead of approximating, I want to find the exact total area inside that curve above the axis or between the axis and the curve. Since this curve is always above the axis, I should get a positive number here. So the exact area is the definite integral from 0 to 2 of the function 4 minus x squared, and then dx. That dx is part of the problem, just like in derivatives. It's telling me to do something. It's telling me to find the Riemann sum and do the limit. So this is defined by the limit n goes to infinity of the summation k equals 1 to n of this function at a special x of k times delta x. Well, now let me fill that in. So this is right here. I'm trying to fill in f of x sub k star times delta x. So I want to fill that in. Okay, well, let's start by calculating delta x. What is delta x going to be here on this one? Let me calculate delta x.
Say minus 0. It's going to be 1. Oh, crap.
Delta x is 2 minus 0 over the number of rectangles. How many rectangles do I have? Well, I don't know. It's n. It's going to go to infinity, so I'm just going to call it n. So delta x is just 2 over n. We follow that?
Mm-hmm.
Okay. Next up, I need to write a formula like I did yesterday for this f of x. We went through that on 2 or 3 cases. We built a formula based on the starting a value. So let's do a left sum. Let's just use left. Okay, left sum. Right sum. Right sum's easier. Okay, right sum. Right sum. Right sum of n rectangles. What's that going to look like? Let's see. That you're going to do f of sum f of. I want to start at a, and then I have to add delta x to get to each of the x values. Well, I don't want to. When I'm doing the right sum, I don't want to start at the left edge. I want to start 1 delta x over. So I start at k times delta x times delta x. Y'all remember going through this? So this is a formula for calculating the x values rather than me trying to manually write them out like I did over there, which I can do when I have a finite number, but I don't know what n is, so I have to build my x values based on a formula rather than calculating individual x values. So I'm going to use this idea to build what goes here. So I got to do function of a plus k. Okay, so function of 4 minus x. X is that thing squared. But what is my a value in this problem? What is my a value? 0. I'm going to write it down just so I know it's there. And then there's a k, which is my variable of my summation. And then times delta x. But what is delta x in this problem? N. And then once you get it, so that's f of x right there. And then times delta x. Delta x is 2 over n. Also, just take a breath and look at that. You see here f of x times delta x. Okay? Well, at this stage, this is like where we were 2 days ago. You just need to, real quickly, you'll distribute out and use the rules of summations to simplify this and come up with an answer. So I don't have time to finish the whole thing, but let's see how far we can get. So K equals 1 to n. Let's see. So I've got a 4 minus, and then I've got a square of k times 2 over n. So that's, I'm going to write that as 4 over n squared k squared times 2 over n.
Mm-hmm.
That looks a little better.
Mm-hmm.
Now, I'm going to, I guess, distribute the 2 over n in. Okay, so let's do that. So limit n goes to infinity, summation k equals 1 to n of, let's write this as 8 over n minus 8 over n cubed times k squared. Well, that's getting to look a lot like the stuff we've done before. So I think in the past we wrote it as a common fraction. So let's see if we can do that. So common fraction here would be, I need an n cubed in the denominator, I guess it looks like. So that's going to be, what, 8n squared minus 8k squared over n cubed or something. I don't know.
Keep it going. It's
All
right.
right. Okay, good. Well, let's finish it up real quick. I'm just showing you that we've got all the tools. We've covered all the tools to handle the problem. This is limit n goes to infinity, summation k equals 1 to n. Now here, I'm going to do some rewriting, if you will. Let's see. So, what can I do? About summation of, I can bring out the 1 over n cubed. That's a constant. And then I got summation of 8n squared minus the summation of 8k squared. Questions? Don't care about that. I'll do that now. Sure. So I brought up the 1 over n cubed here, and now these two I can rewrite. And you could have done it all in a different pattern if you wanted. I'm just kind of going fast in how we did it before, but this summation could be 8n squared times summation of 1. And then this one I could bring out an 8, so I get a summation of k squared. We have formulas for summation of 1 and summation of k squared. We can use those. And so that's 8n squared times n minus 8 times k squared was n times n plus 1 times 2n plus 1 over 6. So now we're down to only n's. Everything's in terms of n, and we got to find the limit as n goes to infinity. I think what we did now is put it back as a single fraction. Probably I shouldn't have done it in the first place. I should have only waited and done it at the end, but whatever. So what is this? 8n cubed, and that's going to be some kind of cube there as well, I think. So actually times 6, so that's going to be 48. And then minus, this is going to be some kind of, I don't remember what it was now, 8 times n cubed plus 3n squared plus, yeah, I think what it was, I don't remember now. And then this will be 6n cubed. That's L'Hopital, so you can do derivatives and stuff. If you do derivatives, you'll come out with, it looks like to me, this is going to come out to be 40 over 6. Whatever that's equal to, divided by 2 is 20 over 3.
Yes.
Okay, so, guess we're out of time. Make sure you practice on 4.2 some more, and go ahead and start looking at 4.3. We started 4.3, gave you a quick taste of it. See you tomorrow.
Dude, I tried sleeping early yesterday. It was crazy. I still can't get used to it. Do you think Mr. Gaddis would be okay if I used the star if David goes out the star?
Okay. So,
I couldn't be doing it, see?
all you have to
See,
do
look at
is
this.
find. What? Yeah, do you wanna look at X star? You gotta like this. and you
The
just
star
use
of Zionism.
That's it.
We should get Mr. Dale to be a
And then you just
Point it
find
back in.
it's so sickeningly simple.
I'm not okay with anything. You know, I wish we had another week. That'd be rough.
But when you get to intervals, it's so much easier.
Don't you mean another week for?
Basically, integrals take 3 months and the sums, it makes it like super.
Well, this is, we are doing definite
What
intervals.
what does the DEX do? What does that do?
What is the star?
The
I'm so
star,
confused.
the star is the symbol
No,
of the people
all
of this.
No, the star means you can pick anyone you want. Like, you know in math how it's hard and then you make some easier way to do it? That's basically
Well, it's
what
not
it
me
is.
doing it, it's some archaic.
All the
ones.
others.
Like when you learn derivatives,
That's true. How
right,
you always
and you
doing
do
the limits.
limits,
We're
and then
not-
you learn
okay,
the
wait,
derivative
so
formula.
this is
This
like
is like
derivatives?
sums for limits, and then you learn the integral formula, and then
There's
everything
integral
changes.
formulas, so why on earth are we doing limits as they approach infinity?
Well, you gotta know what the integral is. What is this?
Oh, what is the integral? It's isn't it finding the perfect area under the curve because n is infinity?
Yes, and you're
That's
using
what-
limits,
It's really fun.
but it's like you learned all this, and then you learned how to do derivatives. It's like
Zion is
summation.
anything you want it to be.
So, did they get easier? So we don't really.
Yeah,
have
it will,
to,
Sammy.
No.
This is, honestly, I think 4.2 is gonna be the worst part.
Sums for the test.
Well, just like
Yeah.
a rough understanding.
Well, 4.2 is
you know,
Riemann,
like limits.
4.3 is, we're actually using integrals.
Well, yeah, but we don't use limits to solve derivatives, we're now using.
Derivatives to
Derivative
solve
rules.
integrals, the vinegar.
But yeah, it's gonna be like, whoa, it's gonna be better.
It's gonna be like, whoa? Whoa.
Kinda like when Brittany asked in class, can't I just do this?
Whoa. I mean, I wasn't even totally against the basic definition of a limit, honestly. Or a derivative, whatever it was, that long thingy, it wasn't that bad to me.
Which one?
I don't know. The one that got replaced with all the rules.
Which one?
Was it the derivatives?
Yeah, it was
Yeah, it was the derivatives. I wasn't.
Still fine.
I'm gonna go study something, I don't even know what yet, but I'm just gonna study for, oh wait, I probably should study my 2-hour test in a few hours. Went to bed at like 11:30 last night, and that's probably the earliest I'm gonna get to bed for the rest of this week. Which is really depressing.